Implicit differentiation explained in 2 minutes. Usually, the functions we deal with have the form y equals f of x, the output y on one side, and everything to do with the input x on the other side. These are called explicit functions. To differentiate them, all we need to do is to take the derivative of the right-hand side with respect to the input. But things are not always that simple. Take this function, for example. Sine y plus e to the y equals x squared plus the natural log of x. You cannot isolate y and express it purely in terms of x. So how would we find the derivative of y in terms of x for such a function? For demonstration, let's take something simpler. Take this equation of a circle. X squared plus y squared equals 9. Say we want to find the slope of the tangent line at the point 0, 3. We can express y in terms of x here, but it would be easier to find the derivative without having an explicit relation. This is what implicit differentiation is all about. We'll take the derivative with respect to the input of both sides. The derivative of a constant is 0. And then, using the linearity of the derivative operator, we have d by dx of x squared plus d by dy of y squared equals 0. d by dx of x squared is just 2x. d by dx of y squared, well, it's 2y, but y is itself a function of x, so we have to use the chain rule and multiply by y prime, or dy by dx. And now we can solve for this derivative by dividing everything by 2, taking x to the other side, and then dividing by y. So dy by dx is negative x over y. To find the slope at the point 0, 3, all we have to do is substitute x equals 0, y equals 3, resulting in 0. So we know that the slope will be 0 at the point 0, 3. And this agrees with what we expect graphically. As we said, this is the equation of a circle centered at the origin with radius 3. At the point 0, 3, we can see very clearly that the tangent line will be horizontal, so its slope is 0. We were able to find the slope of the tangent line at a certain point without knowing what the explicit relationship between the output and input is. And this is what implicit differentiation is all about.